Okay, in this video we're going to go back and do the math to go with the ray diagrams we did in the last video. So we're going to flip back to page 2 of the notes. And the equations we're going to use to find the image, 1 over dO plus 1 over di plus 1 over f. dO is the object distance. di is the image distance. And f is the focal length. Now we're also going to use this equation, SI over SO equals DI over DO, where SI is the size of the image and SO is the size of the object. We use this one to find the size of the image and determine whether it's magnified. Now, we can also define this as a magnification because if the image size is twice the object size, this fraction would end up being 2. It's twice as big as the object was, so the magnification is 2 times. So we'll make a note that M is magnification. So, looking at our examples, okay, we already drew the image for this setup, and we ended up with when the object was out past 2f, the object over here is past 2f away from the lens, we ended up with an inverted small and real image. Now we should end up finding the same things when we do the math. So we'll start out with 1 over dO plus 1 over di is 1 over f. And we're trying to find our value for di. So dO is the object distance from the center of the lens. So counting from the center, it's 1, 2, 3, 4, 5, 6 centimeters. So it's going to be 1 over 6 plus 1 over di equals 1 over f is the focal length. Distance from the center to the focus is 2. So now, I'm going to subtract the 1/6. My common denominator is 6, so that's 3/6 minus 1/6 is 2/6. So if I take the reciprocal, di is 6 over 2, di equals 3. Now, if we look at our ray diagram, we find the same thing. Okay, the center is here, the image is here, the distance between them is 1, 2, 3. So it worked. Now, SI over SO equals DI over DO. The size of the image is over SO, the size of the object is 1, 2, 3, equals DI, we just found was 3, over DO, DO was 6. And if I solve this, I'll get SI is 1.5 centimeters. And if I look, sure enough, the height or the size of this thing is 1.5 from the bottom, the principal axis to the tip of the image. So we'll do the next one. Okay, I find the word from here. It's a 3 centimeter object, so that is the size of the object. 3 centimeters from the lens, that's the distance to the object. And remember, the focus for this one is the same lens. Focus equals 2. So when I plug it in my equations, 1 over dO plus 1 over di equals 1 over f. So 1 over 3 plus 1 over di plus 1 over 6. Sorry, 1 over 2. 1 over di is 1/2 minus 1/3 now, because I'm going to subtract 1/3 from both sides. Common denominator is 6 again, so 3/6 minus 2/6, 1/6. Take the reciprocal, and di equals 6 centimeters. Again, that matched. Okay, here's my center, and 1, 2, 3, 4, 5, 6 away is where my image was formed. The size, SI over SO equals DI over DO. The size of the image over the size of the object is 3 equals 6 over 3. and I end up with SI is 6 centimeters. And if I check that, the height of this from here to here is roughly 6 centimeters. Next one. 1 over DO plus 1 over DI is 1 over F. Okay. DO was 1.5 this time, so 1 over 1.5 plus 1 over DI is 1 over 2. Subtract the 1 over 1.5 from both sides. I get 1 over DI is 1/2 minus 1 over 1.5. My common denominator is 6 again, so it's going to be 3 over 6 minus 4 over 6, which would be minus 1/6. So then DI is minus 6. The minus means it's back on this side of the lens. And if I count back from here, 1, 2, 3, 4, 5, 6. It looks like we're a little off in our diagram, and that's okay. They don't have to match perfectly, but they have to give you the same basic result. Then, so the negative means it's on the left side of the lens and that it's virtual. Virtual images will always have negative values for the DI. SI over SO is DI over DO. SI over 3 equals minus 6 over 1.5. And SI is equal to, ends up being negative 12. The negative actually means it's pointing upward. And virtual images will always be pointing upward, okay, and have negative SIs. And 12 is the height, and it's certainly very tall. Okay, so that probably matches as well. Now, for this one, the trick is, okay, it's a concave lens. All right, looks this way. We have to know that that is a diverging lens, so that F is negative. So F is minus 2 this time. And then our DO is 6, and our SO is 3. So when we do the math, we get 1 over DO plus 1 over DI is 1 over F. 1 over 6 plus 1 over DI is 1 over minus 2. Subtract the 1/6. 1 over DI is 1 over 2 negative minus 1 over 6 is minus 3/6 minus 1/6 is minus 4/6. So if I take the reciprocal, DI is minus 6 over 4, which is minus 1.5 centimeters. The minus there means that it is virtual and that it is to the left of the lens. If I look, it is 1.5 away to the left of the lens. Then SI over SO is DI over DO. SI over 3 equals negative 1.5 we just got for the DI, and DO is 6. If I solve that, I'll get SI equals 0.75 centimeters. And if you look, okay, the height of this does look like it's about 3/4 of a square. So that is how to do the math. The only tricky thing is remembering that if I have a diverging lens, a lens with a negative, diverging lens, a concave lens, it's going to have a negative focal length.